No plan is foolproof. We all must meet our moment of truth. The same shiesty cats that you hang with and do your thing with could set you up and wet you up.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So salts can also be acids and bases. So let's start out by talking about ions as acids. So a salt containing an acid will lower the pH of a solution. You know this already because by looking at the pH scale, the lower the pH value, the more acidic something is. So as an example, let's look at ammonium chloride, NH4Cl, and it's a solid. And so if we have this reaction, NH4 plus aqueous plus water, goes to H3O plus NH3, the Cl minus does not affect the pH because it doesn't give or take a proton. But the H3O plus, the hydronium ion concentration increases and the pH is lowered. So right here, the hydronium ion concentration is what affects the acidity. So there's other examples of salts that are acidic, such as anilium chloride and methyl ammonium bromide, and basically small, highly charged metal cations that act as Lewis acids. So remember, a Lewis acid accepts electrons to increase the hydronium ion concentration. So let me write that down for you. Small, highly charged metal cations act as Lewis acids, meaning they accept electrons. And this increases the proton concentration. So examples of this is Fe3+, which is aqueous, chromium 3+, aluminum 3+, iron 2+, copper 2+, and nickel 2+. And these form hydrated ions, resulting in a release of H+ ions to form H3O+. Also, cations from groups 1 and 2 are weak Lewis acids and they don't generate H3O+. So cations from group 1 and 2 are weak Lewis acids. And they do not generate H3O+. So an example of this is NaCl. Remember, sodium is in group 1, and this would not affect the pH of a solution. No effect on pH. Whereas, remember when I gave you the example of ammonium chloride, it did affect the pH. So very few anions act as acids because it is more difficult for an anion to lose a proton. So exceptions are the anions such as HSO4- and H2PO4-. So now moving on to ions as bases in this small space that I have left down here. A salt containing a base will raise the pH of a solution. If you think back to the pH scale, if the higher the pH value, the more basic something is. And so as an example, let's look at sodium acetate, NaCH3CO2. This is a solid. So if we write out the equation, we have CH3CO2 minus, which is aqueous, plus water, dissociates to OH minus, which is responsible for the basicity, and CH3CO2H. So the sodium plus does not affect the pH, which is why we didn't include the sodium. And as the OH minus concentration increases, the pH increases, making it more basic. So in the case of ions as bases, salts that contain the conjugate base, or anion, of a weak acid will raise the pH by picking up protons. So examples of these is CH3CO2 minus, CO3 2-, or the carbonate ion, PO4 3-, phosphate ion, hydroxide, F-, O 2-, and S 2-. So all of these ions are anions that have the capacity to pick up protons in order to raise the pH value.
It's got me ready to bust, but I can't jeopardize what I've done up to this point, so I'ma get more guys to help me run the whole joint, cultivate, multiply, motivate.